Lesson 9-2, Solving Quadratic Equations by Graphing. Our essential question is, what do the solutions of a quadratic equation represent? So our first question says, how many solutions could a quadratic equation have? And the key concept says, solutions of quadratic equations, there are three different possibilities. The first possibility is that there are two unique real solutions. So two unique, that means two different real solutions. So the solutions are real numbers. The second possibility, there's only one unique real solution. That happens when the vertex is on the x-axis. And then the third possibility, there are no real solutions. Now, underneath this key concept box, I explained that the solutions are the x-intercepts of the graph. So where the graph crosses the x-axis, those points represent the zeros or the solutions to the quadratic equation. So the first graph has two x-intercepts. So there's one x-intercept here, and there's one over here. The second graph has only one x-intercept, and the third graph doesn't have any. So the number of x-intercepts are the same as the number of solutions to the quadratic equation. If the graph doesn't cross the x-axis, it has no real number solutions. And that could mean up above the x-axis, or it could mean down below, like this. All right. Now this lesson, we are going to focus on using a graphing calculator to find the solutions. So we're not going to graph by hand today. We're going to graph on the graphing calculator. So we are going to graph four different quadratics and find their intercepts. So here's our first one. X squared minus 2x minus 8 equals 0. So on the graphing calculator, I am going to enter this in as a quadratic equation with two variables. So y equals x squared minus 2x minus 8. So I'm going to go to my graphing calculator, y equals, and type this in, x squared, you can see the buttons that I'm pushing, minus 2x minus 8. Then I hit the button to graph my quadratic. In order to find the x-intercepts, I need the calc button. The calc button is above the word trace at the top on my calculator, so it's the second function of the trace key. And then if I push number 2, I go to number 2, that's going to find the intercepts for me, the zeros. I can use my arrows to move over, and I want to go a little bit, see how it's moving, I want to get as close as I can on the left-hand side, so not here, but here. This is my left boundary. So you see the question says left bound, so I'm going to hit enter. Then I use my arrow to move to the right boundary, so the right-hand side, and I hit enter. It gives me a guess. I hit enter again, and there's my 0. X equals negative 2. So my first one is negative 2. If I do second and go to calc again, and go to zeros, I can move over to the other x-intercept. Again, I need to stop on the left-hand side first. Here we go, this is the left-hand boundary. And then I need to go to the right-hand boundary and hit enter, and then enter again on my guess. So this one is 4. So now if I go back to my lesson, we have found that x equals negative 2 and x equals 4 are the two x-intercepts for this quadratic. Our next quadratic, you may notice, has not been set equal to 0 yet, so I need to move the 10 over to the other side so that I have x squared minus 6x minus 10 equals 0. So I'm entering in y equals x squared minus 6x minus 10. We have to have the entire quadratic on one side. It has to be set equal to 0 to find the zeros for the function. Back to the calculator. So y equals, I can clear this one. Now I need x squared minus 6x minus 10. Graph. Second function of the trace button, so calc. Number 2, we're looking for zeros. I need to move over to the left-hand side. This is my left boundary. Hit enter. Then move over one to the right-hand side. Hit enter. Guess. So this one is negative 1.35 or a negative 1.36, we'll say. Negative 1.36. I'm going to write that one down before I forget. Maybe. So x equals negative 1.36 or second, calc again, looking for my zeros. I need to trace and move over to the other side. There it is. So this, yep, so this is my left boundary. This is my right boundary. So I hit enter and then enter again. 7.358, so 7.36. So far both of these have had 2 solutions. Next up, 2x squared plus 7x plus 3 equals 0. So y equals 2x squared plus 7x plus 3. Two x squared plus 7x plus 3. Graph. Second, calc. Zeros we're looking for. Move over. Left boundary, enter. Right boundary, enter. Enter again. Negative 3 for this one. I'll remember that. Calc. Zeros. Left boundary, enter. Right boundary, enter. Guess. Negative 0.5. So negative 3 and negative 0.5. All right. My last example, x squared plus 2x plus 3 equals 0. So y equals x squared plus 2x plus 3. X squared plus 2x plus 3. Oh, this one doesn't have any. All right. So, no real solutions. Okay. Because if the graph is completely above the x-axis or completely below, there are no real solutions. Now what we didn't see was one that had one solution. So I'm going to just make sure that I show you one that would have one solution. So I think that this one, x squared plus 6x plus 9, I think that this one's going to have one solution. So x squared plus 6x plus 9. Yeah, this one has one solution. So if I do my second calc, zeros, Let's say that looks like the left boundary. Oh, no, I didn't. I don't think I did a very good job on that one. I'm going to try that one again. Okay, zeros. I'm going to pick this one for the left boundary. This one for the right boundary. So I think because this one, it looked like there were so many points right there. You can tell that this one, the zero, it says negative 2.99999, so really it's negative 3. But it was hard for me to figure out what to use as my boundaries. So if I try it again, if I use this one as the left boundary, and this one as the right boundary, yeah, still the same. So it rounds to negative 3, and there's only 1 0. There's only 1 0. If I keep on tracing, it doesn't intersect twice. It's not, there aren't 2 spots. And you can zoom in if you wanted to. You can zoom in and look at it if you want to be sure. Like that. You could keep zooming in. Oh, need to move over. Okay. Need to make sure before I zoom that I've got my trace where I want it to be. Okay. So now I can zoom in. And yeah. So anyway, this one only has 1 and it's negative 3. So you should be able to use a graphing calculator now, write a summary describing what you do, use a graphing calculator to complete your problems.